All right, very well, guys. So today we're going to continue with our new chapter, chapter 17. And what I would like to do actually is I want to do a quick derivation of, the moment of inertia and, why the moment of inertia is actually showing up. And as you remember, the equation of the moment of inertia was equal to r squared dm, where you integrate this guy from 0 to m. And r basically is about an axis, right? So r here is the radius. And if I were, finding the moment of inertia about, let's say, this point P, I would write point P, and then R is actually measured about point P for all this rigid body, right? So it is basically R, that R is basically the distance of this dm right here, and with respect to that point P. So let us do that. Here's what, so basically we know Newton derived his law, F was equal to ma, and this basically applies on a single particle. So Fi is actually equal to MAI, and basically I could have, a rigid body essentially is a bunch of points, right, that are connected, and I know, this guy is going to have Fi, etc. Then, this point right here will actually have MAI, right? And then this is basically what I have here. Fi is equal to MAI. Now, if I basically introduce the concept of torque, just like what I mentioned last time, torque is actually equal to what? R, right, cross F, right? But this torque is about a point or an axis, right? So if I'm looking at the moment of the force Fi, I'm going to put Ri with respect to some point P. So this is the torque of this force about point P, and then point P could be anywhere on this rigid body. So that is the equation of the torque. So torque is equal to R cross F, and here you are finding the torque of this force about this point P, and then like I said last time is basically ultimately if you do this, the cross product of this will actually be equal to this force multiplied by that distance. If you do the cross product, it will actually come up automatically. So here's what we're going to do, right? So a rigid body is essentially a bunch of points, and what I'm going to do is I'm going to do on this F, I'm going to do the torque of this and then the torque of that. So I'm going to do R, right, I with respect to P cross Fi is actually equal to R I cross P cross MA and MI, right, and the acceleration here of point I, right? Okay, and here basically all that I'm doing is basically I'm doing the torque about this point, and then I'm doing the same thing that I'm doing here, right? So I can totally do that. So because it's a rigid body, basically I'm going to put a summation over here, right? And I'm gonna do I is equal to 0 to I is equal to n. So here I'm assuming the rigid body is made out of n points, right? And I'm starting at 0 and I'm ending at n. Right, so this is all that I'm doing here, right? So I'm assuming that the rigid body is a bunch of points, and I'm trying to apply Newton's law on each point, right? And the way to do that is basically I'm taking the cross product on all these points, all right? So this guy is actually the torques, right? So sum of the torques about point P is equal to this guy, right? So basically, essentially, I'm taking that inertial torque, right? MI, AI. Is that clear, guys? So now I know this is acceleration of every point I. So here, basically, you need to know the acceleration at every point I, and this is MAI plus 1, for example. And then you need to know all these points. Instead of knowing this, I know I can actually relate all these acceleration to the acceleration of point P, right? How do I do that? So basically, I can use a simple equation, right? So I know AI, right, is related to the acceleration of point P on the rigid body, right? AP plus alpha cross R I with respect to P, right? Minus omega squared R I with respect to P. So all that I did right now is I'm doing the torque of the individual accelerations, right? and I'm relating these individual accelerations to the acceleration of point P and then alpha, right? And also omega. So let us continue from here on this new page so you guys can see that. Okay, so so I have my torques about point P, right? So sum of the torques, which is, you know, obviously a vector, is going to be equal to now summing these tiny torques of the individual particles that make up the rigid body is R I with respect to P cross MI, and I'm going to rewrite AI as AP plus alpha cross RIP minus omega square II with respect to P, right? And can someone tell me what is that? So I can basically expand that, right? And this is sum of I is equal to 0 to I is equal to N. So the first one is going to be what? RI with respect to P cross MI AP, right? Plus the second one is going to be RI with respect to P cross alpha cross RI with respect to P. And the third one is going to be minus, right? Omega square, sorry, RI with respect to P cross RI with respect to P, right? And can someone tell me what is this guy? So this guy is what? Omega square, right? RI with respect to P cross RI with respect to P. Can someone tell me what is that term? The last one? What is this guy? What is the cross product of, you know, of a vector A 0. Cross A? 0, exactly. Why? Because the angle between these two vectors is 0, right? And then we know sine of 0 is 0. So always, guys, the cross product of the same vector will always be 0, right? The dot product of the same vector is 1, right? So this guy is 0, and this actually simplified now, and then I'm only ending up with this. How about this guy? What is RIP cross alpha cross RIP? Well, let's take a look at it, right? So this is a rigid body, right? And I know alpha is going to be, you know, perpendicular to this. It doesn't really matter, but I know it's perpendicular to that. RIP basically is a vector from, you know, the ice particle on this rigid body and then point P. So this is a vector RIP. So, you know, so alpha, right? Alpha cross RIP. So alpha cross RIP is this vector, right? So a vector perpendicular to that. You guys agree? So this guy is alpha cross RIP. You guys agree? Okay. And if I do it one more time, right? And then if I do actually RIP cross this guy, what do I get? Can someone tell me? Maybe I'll help you. So what if you have I and then J frame here? What is RIP cross alpha cross RIP? So this is RIP, right? This is your vector RIP. So RIP cross this vector, right? So you're taking this vector cross this guy, you're going to be back up, right? In the K direction, right? So this vector cross this vector, I'm going to be perpendicular to this in the K direction, right? So I can basically write this as alpha, right? And by the way, this is missing the M, right? So the M is multiplying all these MI, and here I have MI, right? So M is multiplying all these. So I have it on the first one, it should be here. Okay, so so RIP cross alpha cross RIP, I can actually write this as, right? So I'm gonna write it here, right? So RIP cross alpha cross RIP, I can actually write that as alpha R square RIP K, right? And all that basically is in the K direction. Okay, so let me come back here and then rewrite that. So what are the torques equal to? So the torques are going to be equal to the summation of I equal to 0 to I is equal to N, right? And RIP cross, you know, MI is a scalar, so you could move it anywhere, AP plus mi, right? Alpha ri with respect to p square, right? And then this is k, and then this is all done together, right? And I'm going to, separate these two. So I is equal to 0 to I is equal to n. And here I'm going to move the mi to the front. So that would be RIP cross AP plus the summation of, and I'm going to put alpha on the inside, and I'm going to be here I RIP squared, and this is K, I is equal to 0 to I is equal to n, right? So I'm doing this on all these particles, right? Can someone tell me what is that? You can even put K on the, what is that equal to? Can someone tell me? What is that term? This guy, summation of m r squared.
Is it I?
Exactly, but what I?
IP.
IP, exactly. So this is a moment of inertia about point P, because you are doing this with respect to point P. Okay, so let us rewrite this one more time. And here, you are going to end up as what? So summation of I is equal to 0 to I is equal to n, mi RIP, right, cross AP. So K and then alpha, so plus alpha K multiplied by IP, right? Or alpha IP, alpha IPK. So let me just put K on this end. So this is alpha IP, right? This is, the rotational inertial torque, right? Alpha times IP. But here, the moment of inertia is actually calculated about that point P, for which I'm basically doing the torques, right? Remember here, if someone talks about point P, so you need to know the moment of inertia of that rigid body about that point. Okay, so we still have these. Let me rewrite that and then kind of simplify that further. So here, I'm here, right? So I just sum the torques, right, about point P, and they are vectors, and I'm ending up with I is equal to 0 to I is equal to n. So I'm doing this on all the particles on a rigid body. Mi, or I with respect to P, cross the acceleration of the point P. So I need to know the acceleration of point P, plus alpha IP, and then this is in the K direction. How about this guy? Can someone tell me what is that guy? So if I actually do the summation, right? One thing in engineering that is very important is that you should be able to kind of like simplify stuff, right? If I try to actually simplify that, I'm going to end up with what? Like M1, first point, R1P, right? I can basically do all that summation, and then all this is multiplied by AP, right? So I can write that plus M2, R2 with respect to P, plus M3, M3 times R2 with respect to P, etc. Cross AP, right? You guys agree? So this is essentially that, plus obviously the rest of the stuff. What are this guy? What are these guys? Obviously these are vectors, right? What is that guy equal to? When you do, M1 x1 plus M2 x2 plus M3 x3, this is like getting the center of gravity of the rigid body, right? And these guys are going to be equal to, you guys, total mass of the rigid body, R G with respect to P. So it's like you're finding an equation of the center of gravity with respect to point P. So this whole thing is actually equal to that. You guys agree? Because in reality, M1 R1P plus, let's say, M2 R2 with respect to P plus M3 R3 with respect to P is actually equal to M RG with respect to P. So if you actually have, just 3 points, randomly, right? If you have some frame like that, and I have point 1, and this guy is R1, M1, and I have another point, M2, and this guy is my R2, and then I have another point here, let's say, right? And then this point is M3, and this guy is R3. If I ask you to find the center of gravity for this array of masses, how do you find the center of gravity? You guys know probably, right? You can find, for example, x bar, okay? X bar is going to be equal to m1 x1. So you're looking at, x1 for m1 plus m2 x2 plus etc. divided by m1 plus m2 plus the remaining masses. Are you guys familiar of that, right?
Yes.
Okay, very good. So this is essentially, right? So these guys are actually equal to mRg with respect to p, right? So if you want to find the center of gravity, right? Because the vector contains both x and I, so I can actually write the center of gravity for, and obviously here I can do y bar, right? So I can actually say Rg, is equal to what? M1 R1 plus M2 R2 plus M3 R3 divided by what? M1 plus M2 plus M3, which is the total mass of that, right? So this guy is M, and then I'm gonna actually take that here. So mRg is actually equal to M1 R1 plus M2 R2 plus M3 R3, right? So this is the equation of the center of gravity. And here I have Rg, right? So basically here I'm finding the equation of the center of gravity, but I don't have any reference. Essentially here I'm finding it with respect to this point O, right? But I could, in a similar way, I could do it with respect to any point. So this guy could be point P, right? And if all these radiuses are about this point P, then I could be using another subframe basically that has all this. But I'm pretty sure you guys can see why this is actually true, and it makes perfect sense. So I'm going to rewrite this summation as, just directly M R G with respect to P. So if I'm here, right, let me actually write it on a new page. So here, summing the torques about point P is actually equal to I is equal to 0 to I is equal to, N. Here, basically, you're simply assuming that cross AP plus alpha IP, okay? And I said that this guy is equal to what? Is equal to M, the total mass of the rigid body, multiplied by Rg with respect to P. So now the center of gravity is actually coming in cross AP, right? Plus alpha APK. Okay, so to recap, right? If I have a rigid body, right, and I have a bunch of forces applied on it, right? F1, F2, F3, right, etc. So these forces have to be equal to what? So first of all, I have to, if I'm doing the torques about point P, so I need to know this point P on the rigid body, right? And I also need to know where the center of gravity is, because I'm using that. And essentially, the sum of the torques about this point, so if I'm doing all these, moment arms of all these forces, etc., this is like I'm doing that, right? MRG times AP. So this M can actually go here. And I need to know, first of all, the acceleration of point P, okay? And this M could actually be here. So I have MAP, so the total mass of the rigid body, multiplied by the acceleration of point P, for which I'm trying to sum the torques, right? And what am I doing? So I'm taking the cross product of RGP cross this guy, right? RGP is a vector that points from P to G, right? So RG as G from P. So this is my RGP, and I'm taking this MAP and I'm putting that here, right? And I'm adding this guy alpha IP as my as my inertial force, right? So this is one of the ways that you can do, right? So you can sum the moments about point P, right? When you are doing the forces, you can sum the moments about point P, right? But you need to know the acceleration at point P, okay? Right? You put it right at the center of gravity, right? And then you find its moment about point P, right? Does make sense? Plus, you have to add alpha IP. So you need to also know the moment of inertia about point P. So in many cases, this can work, but this sometimes may be inconvenient because most of the time, the force will actually give you the acceleration at the center of gravity. They don't actually give you the acceleration at point P. So I need to somehow convert that and get the acceleration directly at the center of gravity. So I want to, rewrite that equation another time so that I, because I don't know AP, right? Or I may not know AP easily, but if I use here, somehow if I, rearrange that equation and then use the acceleration of center of gravity, I know I can directly get the acceleration of center of gravity from the forces, right? Because I know some of the forces on the body has to be equal to ag, right? And then I can actually get ag from here, right? And then I can take it from here. So, the easiest way to actually, I can rewrite AP in terms of ag, and I know AP has to be equal to what? ag, right? Plus alpha cross rp with respect to g minus omega square rp with respect to g, right? And what else do I know? Okay, let's do this step and then we can do the last step after this. So now some of the torques about point P are going to be equal to what? M, right? Rg with respect to P cross, so I'm going to replace AP by this, Ag plus alpha Rp with respect to G minus omega squared Rp with respect to G. So this is gonna end up, so R G with respect to P, right? And I have the M before. And we have this term, right? We don't want to miss the last term, alpha IPK. All right. So the first term is going to be what? So MRG with respect to P cross AG, right? What is the second term? It's going to be plus M RG with respect to P cross alpha cross RP with respect to G, right? Plus, what is that term? RG with respect to P cross minus omega squared RG with respect to P. Can someone tell me? So basically what you are doing here, you are doing the cross product. I'm sorry?
دكتور في بس أسألك سؤال صغير.
Yeah, sure.
اليوم رح تنزل الفيديو تبع تسجيل اليوم؟
Yes, yes.
على بلاك بورد كلهم بينزلوا؟
Yes, so we have the one and then we have the one for yesterday. So I tried to upload the one for yesterday, but it took so much time and then ultimately it failed. So I'm going to try to re-upload it after this. So the one from, I'm sorry, Wednesday and then this one. Okay, but let's continue here though, and then we're almost there, guys. I know this is a little bit, challenging, but I want you guys to know, the concept behind that, and the fundamental. So here, RGP cross RGP will be basically 0, right? Because same vector, right? RGP cross RGP. So this guy cross this guy will actually be 0, and then you only are going to remain the only remaining term is going to be this guy, right? So plus alpha IPK. Okay.
دكتور ليه هذه الايكويشن اللي قبلها MRGP cross alpha cross RPG ليه ما كمان equal to 0?
This one?
Yes. ما إذا هديك كمان RGP cross RPG equals to 0 ليه مش هي كمان؟
Okay, the reason is, so here RGP cross RGP, because this is the same vector, right? But here I have RGP. First of all, I have RPG, which is minus, obviously sin 180 is with 0, but actually we have the alpha in the middle, right? So let's look at that, right? Let's look at that. So what is RPG? So let's say this guy is, let's say this is P and then this is G. Then this guy is RP as viewed from G, right? So this is that guy, right? I know alpha will always be perpendicular to it. So like I said, if you have a cross product of multiple elements, you want to start from the last two. So alpha cross RPG is going to be this vector, right? So this guy is this guy, alpha cross RPG.
Yes.
Okay. And then if I do actually RG with respect to P cross this guy, so now I'm going to actually come backward, right? So RG with respect to P, which is this guy, right?
Yes.
So RG with respect to P cross this guy, it's going to be in a minus K direction, You agree? Right? Because
Yes.
we still have the same frame, right? So this guy, so this term is in reality equal to how much? Minus m alpha r square. Doesn't really matter here anymore, p with respect to g or g with respect to p. What matters is that this has to be in a minus k direction. And guys, here we're doing with planar torques, right? Torques are rotational, and then you see that all the units are actually in the k direction. All right, so I'm just
دكتور سؤال
yeah.
هون ما طلعش زيرو لانه في كروس الفا بالنص ما هيك؟
Exactly, yes, because you have the alpha. So alpha cross rp with respect to g gave you this, right? And then rg with respect to p, which is in this direction, rg cross this guy is going to give you one that is in the opposite k.
Okay, thank you.
Okay, so I'm going to rewrite this one more time here, and then we're almost done here. So sum the torques about point P is actually equal to, and by the way here, because I have the mass, so I'm going to actually put the mass in front of the A just so we can rearrange it. So here I have R G with respect to P, MAG, right? The second term is minus M alpha R square P to GK plus the last term alpha IPK. So you see basically this guy and this guy are in the k direction. This guy will be in the k direction ultimately because you have the radius and then you have the acceleration of center of gravity. If it is a rigid body, assuming only planar movement, then let's say this guy is G, right? Then this guy is MAG. And let's say point P where you are trying to, sum the torques about. So RG with respect to P is this guy. So this guy cross this guy has to be in the K direction. And these two are both in the I and then J direction. All right. So now the last thing is I have I in terms of P, right? If I want to get the moment of inertia about point G with respect to P, I know I can actually use the parallax theorem. I know IP is actually related to IG, right? By the parallax theorem. So I have to actually add this distance, right? You guys agree, right? And most of the time, the table will actually give you IG, and then, so I want to actually take this guy and then I'm going to write it here and see what happens. So I'm going to end up with RG with respect to P cross MAG minus M alpha K plus alpha IP. What is IP? So it is IG plus M R squared P with respect to G, and then in the K direction. And by the way, this mass is capital, right? Okay, so you see here that actually this guy and this guy will cancel out, right? M alpha RP with respect to G squared, and then alpha plus M alpha RP with respect to G squared. So this guy and this guy will actually cancel out, right? And you actually only end up with R G with respect to P cross MAG plus alpha IGK. Okay, so this is the sum of the torques at any point on a rigid body, right? So the sum of the torques at any point in a rigid body, all you have to do is just simply know the moment of inertia about the center of gravity, multiplied by alpha, and then you do the moments about AGN. And this is what I was describing in our earlier, the first, concept in our first Wednesday lecture was this. So what that really tells you is if you have a bunch of forces applied on a rigid body, no matter where they are, right? Let's say you like that point P here, right? So let's say this guy is F1, this guy is F2, and this guy is F3. If I, let's say point P is here, but the center of gravity of that rigid body is here, right? Then what happens basically is, the moment of the first force is like that, moment of the second force is like this, right? And then the third force maybe doesn't have any moment about that point. What do you actually have to do here is all you do is you just find MAG about the center of gravity. So these forces will ultimately give you one acceleration vector, right? Let's say this guy is MAG, right? You want to add, so this guy is MAG, and then IG alpha is you get the moment of inertia about this point. Okay. So let's say this is your IG alpha. So all you do is basically you have to add this guy, and then you have to add the moment of this guy about this force, right? So this is going to be your RG with respect to P, right? Obviously, as a vector, it's going to be like that. But when you do the cross product and you multiply all these, the actual value of this in the K direction would be only that distance multiplied by this vector. Okay, guys, and this is really, this is the last concept that we actually are going to be doing in our class. So this basically summarizes our course, and you know, we won't be covering any more topics. So if you are able to understand up to this point, then there won't be any new theory for you guys to learn. So this is the last thing, and then I'm not going to ask you guys to derive this, obviously. I just need you guys to be aware of this equation and why this is actually true, right? So here we're not actually calculating the moment of inertia about point P, right? We're actually using IG about the center of gravity. And this actually simplifies dynamics and the way you analyze the dynamic systems drastically. Okay, so I think that is actually it regarding that, and we can basically begin to solve some problems. And what I'll do is let us actually begin by solving one of the problems that we have in our slides. Okay, guys. So we are going to continue with this example, and in this example, basically, we have a cart, right, or a crate, basically, that sits on a cart, and the crate is 150 kilogram. It's basically this wooden box, and it's sitting on a crate, which is basically, or I'm sorry, cart, which is 10 kilogram. So the cart is 10 kilogram. And what I would like to do is would like to find out what is the maximum value of the force P that could be applied so that there is no sliding between the box, basically, and the cart. And we also need to find what is the maximum force P so that this crate doesn't basically tip, or the box wouldn't tip on this object. So the way we're going to analyze this is we're going to start by doing a Freebody diagram on here. And let me just stop sharing that so we can evaluate it. All right, so this is what we have. All right, so we have this, you know, block, basically, which weighs, you know, and it's sitting on this platform. And this guy is basically being pulled by a force P, and you know gravity is acting downward, and the mass of the smaller guy is m. All right, and then they tell you that the coefficient of friction in here is actually equal to μs. Okay, how are we going to analyze that? So what we have to do is we have to draw a Freebody diagram, right? And then each mass will have its own Freebody diagram. How does the Freebody diagram look like for the top mass? Can someone tell me quickly?
The normal reaction and its weight.
Okay, so the weight will always be at the center of gravity, right? mg, and then we have a normal. Okay, what else?
Friction.
Should I put P? How does what is a friction force? Can I put like P here?
No, not P.
Not P.
What am I missing here? So
μs times mg.
okay, does the friction, is it like that, or is it in the opposite direction?
The opposite.
لا هيك مظبوطة.
Why is it in that direction?
لأنه لما تشد الكارت اوكي او هذا الشيء الاوبجكت بده يدفش لورا فالفريكشن بتخليه محله ما هيك؟
Not quite. So how is that object moving? To the left or to the right?
هو حيروح على الرايت.
This object?
Eh.
No, it's impossible, right? So there's only one force applied on this object. So if you are moving this guy to the left, then the only possible force on this guy is to the left, and this guy can only move to the left, right? And you know, the reason for that is the friction can only be applied like that. Like, you know, if I have a pen on me, even if I move really fast and, you know, it might roll, but ultimately it actually has to move toward me, right? And the reason for that is you only have forces on the left side. You don't have any force in the right direction. Does this make sense or no? So this is the only force, and then this guy has to be moving to the left. MA. Okay, and how about the forces on the platform? So the forces on the platform, basically, they would be equal and opposite. So if the friction is like that, then the friction on this guy is like that, and that force P is going to be like this. And again, we can actually draw this acceleration of this guy. And let's say this is your center of gravity, then you are going to actually have M times A. Okay, here's what is happening, okay? Every time where you have to deal with friction, you don't know the value of friction, right? The friction could be more than the static friction, or it could be less. What you should always do is you should assume that, first of all, you assume by saying that there is no slip, right, in the system. And if there is no slip in the system between this guy and this guy, they must have the same acceleration. And here I can put A, and I can put A over here. And if they don't, if they have the same acceleration, basically you will be able to solve for the friction force. And once you solve for the friction force, you can test your assumption. If that, right? So first of all, you assume, so the first step is, you know, assume.
Doctor, I have a question.
Let me just finish that so we don't lose our thought process. So first of all, you assume no slip, right? After you assume no slip, then you can solve, assume no slip, and then here you set accelerations to be equal, right? On all rigid bodies, right? Accelerations equal in case of a linear movement, right? So then you want to solve for A based on, if you set the accelerations to be equal, you'll be able to solve for A. Then 3, solve F, solve for friction. If friction is greater than mu s times n, it means that there is slip, right? Slip occurs. If there is slip, then your friction is actually equal to mu k times n. So now you actually know your friction, and then you can use this value of friction to solve for A again, right? So this guy will have its own F, this guy will have its own F, which is equal. And then the balance between the force and the friction, which you know, and you know the force, basically, you can basically get that acceleration. Okay, and vice versa for this guy. And this problem, basically, we are not going to assume that there is no slip or slip. And this problem, basically, they tell us directly when we need to solve for the force such that this guy is at the verge of sliding. When this guy is at the verge of sliding, then what is the value for the friction? When it is about to slide, then the friction is going to be equal to what? It's going to be equal to at maximum friction, okay? When it is about to slip. When it is about to slip, the friction is going to be equal to mu s times n, right? Right? So here, at the verge of slipping, F is equal to the maximum, which is equal to mu s times n, right? So F is going to be equal to mu s times n, which is going to be equal to n is equal to mg here, right? So this guy is actually equal to mu s times n, which is equal to mu s times mg. Can you get the acceleration from here? Well, they have the same acceleration, right? I can take the first rigid body. If I sum the forces in the x direction, I'm going to get F is equal to ma, which is equal to v s times mg, right? So here you sum the forces on the right side, right, on the bigger mass, right? And if you do that, Let's do this like that so you can see it. If you do that, basically you are going to do what? All right, you will actually get what? F, right, has to be equal to MA, ما هيك؟ And at the verge of slipping, F is equal to how much? Mu S times mg, right, which is equal to MA. So therefore, A is equal to mu S times G. All right, so we got A, and we need to solve for P. So to solve P, you can use the second one. So summing the forces on a smaller mass in the left direction, and you are going to end up with P minus F, right, is equal to MA. So P is equal to F plus MA, and I know F is equal to mu S times mg plus MA, and I know A was equal to mu S times G. So P is going to be equal to big M plus smaller m mu S times G. Okay. Or it would be basically equal to m plus small m times A, which kind of makes sense because, you know, if the whole rigid body, if you take the whole system, you know, simultaneously, if you sum the forces on the whole system, F and F will actually cancel out, right? And you only end up with P is equal to m plus m, right? It's a linear system, obviously, so you can basically add them together or subtract them together. We're not going to subtract them. But if you sum the forces in the x direction, you're going to get P is equal to m plus m times A because they have the same A. And that stems basically from what? From the fact that they are not sliding. And since they are not sliding, then they have the same acceleration, right? Now, if, you know, if I gave you the force P, then basically, you know, if P was known, then you can see if the system is going to slide or not slide, whatever, based on finding the force, the frictional force. Okay, now the second portion of that is we would like to see if this guy is about to tip. Can someone help me and then tell me how can I find when this object will begin to tip? By the way, this guy is missing the force here, right? Smaller guy, which we don't need anyway. And then, you know, normally here's right, and 1 and then 2. Can someone tell me how can I solve or how can I find the maximum force so that this guy will not tip?
الان بتصير زيرو وقتها
Will n be
ببلش
0? Okay, let's do something. Let's say that this guy is a, you know, has dimension of b, which is a base, and the height of this guy is h, right? And so basically, when this guy is about to tip you, you're right. So n becomes 0, but in reality, n doesn't become 0 because you always need to carry the weight. So n basically will actually shift to the right, right? And when n basically shifts to the right, then this guy is about, you know, is tipping. Okay. And let us take this point, and then we're going to assume that this guy is point O. Okay, so how can I find that P, the maximum force P that would do that? So what I can do basically is I can actually sum the moments about point O on that rigid body, right, on the big block. So if I sum the moments about O on the bigger block, and then I'm going to assume this is my clockwise direction, what would the moment look like? Can someone tell me? What is the moment of, you know, mg, for example?
mg times,
b over 2.
Exactly, mg times b over 2. So in reality, you always have a moment by the force n, right? So these moments are basically being in equilibrium by ma, okay? But here, how come I don't have ig alpha, by the way, here? And then here we
لأنه the object is not rotating.
Exactly, not rotating, right? Not rotating. That is very important. Okay, so these forces, right, or these torques basically have to be equivalent to the moment of this guy, right? So this point O is actually also here, right? So mg, so as a result of, at some point, basically, n would basically be coming forward, right? What is the moment of the friction force about point O?
Zero, because it's
Zero.
passing.
Exactly. So we're done with the left side. How about the right side?
MA times H over 2.
Exactly, m times h over 2, exactly. So m and m will cancel out, 2 and 2 will cancel out, so a is going to be equal to how much? G times
B over H.
b over h, exactly, right? So basically the acceleration can be larger if the system has very small height. What happened to a?
It will increase.
It will increase, exactly. So the smaller the h, the more the acceleration that you can have on this block before it begins to tap. So now if I want to connect A to P, how can I connect A to P?
P equals MA.
Okay, so first of all, you know the acceleration. You can find the friction, okay? Right? So what is the friction in this case? You can sum the forces, right? If you sum the forces in the left direction, what do you get up with? F has to. So these guys, so these forces are always equal to these forces in that direction, whether it is horizontal or vertical. So if I sum the forces in the x direction, I'm going to get F is going to be equal to what? M times A, okay? Right? And I already solved for A, so it's going to be M G B over H, right? How about the force P? So now I know the value of the friction. Friction is equal and opposite. So now I'm here, right?
The P equals M plus MA and A equals mu S times G.
Exactly. So if you do that, some of the forces in that direction on smaller mass, I'm going to end up with P minus F, which I have it here, right? Minus F has to be equal to what? This
small
MA. Okay, small MA, and then they have the same acceleration, okay? Here we're assuming that we're not assuming sliding in and tipping, right? So they have to have the same. So P has to be equal to MA plus F, right? What is F? Is equal MG plus H, right? So F plus MA, and they have the same acceleration, which is G times B over H. So your friction is equal mg B over H, and then the acceleration is M again, G P over H. So essentially, it is equal to M plus M G B over H. Does this make sense, guys? So this is the force for tipping. Okay, and the force for sliding was equal to how much? Same thing, M plus M, mu S times G. So the other way of actually doing that would be to, do the forces on the whole system. And when you do it on the whole system, F and F will actually be equal. So you know that P will always be equal to M plus MA, okay? So it's like, you have a car, right? And no matter how many people are in the car, the total force is total mass of the car, whatever that you have, provided that all the objects in the car have the same acceleration, okay? They're not moving in the car or whatever. Then you can say the total force that is need to push the car is equal to the total mass times the acceleration, okay? And this is why this is total mass and they have the same acceleration. And
دكتور وقت يصير في tipping
yes,
فيك تفسر أكتر ليش الN بتزيح على الO؟
Yes, sure. So basically
أول شيء tipping يعني بتعلى عن الأرض أو شيء.
Yeah, so tipping basically, let's say this guy is like that, right? So it's tipping basically, it's just about to do this, right? So this is basically what I mean by basically tipping. Right?
Okay. Okay. الآن بتزيح محل مدائق بالأرض.
Exactly. So this guy basically will begin to rotate like that, right? So this line would actually begin to look like that, right? So this line, which is here, it's gonna tip, right? So this guy would look like that, for example. Right?
Okay.
Okay. And by tipping, basically the normal force which was here, it's gonna go here. And why is it tipping? Because obviously if the acceleration is 0, what is n going to be? Can someone tell me? If a is 0, then n is gonna be at the middle, right? But by increasing a, n is gonna be it will be always there. But if a is basically greater or equal to the value that we just solved for, it means that n actually has to be here. Why? Because this guy, mg times this guy, is in equilibrium with ma times this value. right? We can't basically solve exactly what n is going to be, but we know that at some value for the acceleration, n will basically disappear from here. Why? Because the moment of mg times this will be balanced by the inertial acceleration of this guy. So basically, you're moving this platform very quickly, and you're causing this guy to tip. So we're going to be solving some more problems on this, and I think you guys.
دكتور اساس سؤال بس عن هالشغله.
Yeah, sure.
الفريكشن بتضل هي ذاتها لو حتى البلوك اللي واقف على بوينت وحده.
Exactly, yes. The friction will always be equal to well, هون the friction is equal to what? The friction is going to be equal to ma, ما هيك؟ So whatever that you value for the acceleration, you're going to get the friction, because the only force that is moving this object is the friction, right? The only force that is actually moving this guy in the left direction is a friction force, right? ما هيك؟ So if you're moving
الفريكشن على السيرفيس اكبر، مش لازم تكون اكبر من الفريكشن على نقطه.
Okay, so you're talking about the stress sort of. Okay, as بتصغر الاريا, then you're gonna have more stress on here, right? Which you're gonna study later, the force over the area, right? So if the area reduces, you're gonna have more stress. So maybe this guy can damage the platform if it's tipping, maybe, right? And that is by looking at the stress. This is a different thing. But the total value of the friction which is basically pushing this guy to the left, will always be, equal to this ma.
Okay.
دكتور
Yes.
انا اول شيء لما قلت انه الاوبجكت حيروح على الميلة اليمين، مش انا قصدي مش كله سوا، قصدي انه لما بدها تمشي حتقب هيك، مش عم تروح على اليمين البلوك لوحده الكبير.
It will move to the right relative to the block, right? So this guy will move to the right relative to this, but ultimately it is actually always moving to the left. It never actually moves to the right. Okay, this object never actually goes to the right in terms of the absolute position, but with respect to this, then maybe yes, right? If it's tipping. Okay. Let me give you guys you're asking me these questions. I want to give you guys a problem that I will solve on Monday, right? What if you have a truck? All right, let's say you have this is a kind of truck. It has wheels on it, and let's say the truck is actually accelerating with an acceleration to the left that is a capital A. All right, and on the truck you have a barrel. All right, and the center of the barrel is I'm gonna call it G. And can you find if I tell you this guy has a radius R, can you tell me the acceleration of G as a result of the truck acceleration? And tell me if will this guy move to the left or to the right relative to the ground, right? So relative to a fixed frame, do you think the barrel will actually move to the left or to the right?
Relative to the ground.
Relative to the ground. Do you think the barrel will move to the left or to the right if the truck is accelerating?
To the left. Oh, okay. ما هلا يمكن.
Okay, well,
Right.
think about it, right? Think about it, right? Draw Freebody diagrams, do whatever you want to do. And I want to tell you that the floor, basically, there is no slip. So there is no slipping between this guy and this guy. And this is what we're going to do on Monday. On Monday, we're going to attack, rolling motion with friction or without friction. But, give it some thought. And, let me know on Monday, how do you think this guy will move relative to the ground and also relative to this guy. Okay, guys, so we're done for now, and thank you. Have a nice weekend, and bye-bye.
Doctor, can I have a small question to make sure about something?
Yeah, sure, of course.
You will choose the highest grade between the makeup and the exam 2, right?
Yes.
Okay.
Yes, I will.
Doctor,
Yes.
can we check out? Can I know where are the mistakes in my test too?
Yes, of course. Well, let me